Welcome, grade 9, to Unit 8. Today we're going to talk about circles, properties of tangents to circles to be specific. So I need you to get a ruler, and I need you to get a protractor, and I need you to get some paper. Actually, you can use the paper that's down here, actually. So what I want you to do is I want you to follow these instructions. Draw a circle with a diameter of 5 centimeters, and mark the center point, O, before you draw it with your compass so you know where it's at. Mark a point outside the circle as N, and I'd like you to do all that, and when you're done, I'm going to show you what it should look like so you don't have any problems. So there's what I'd like you to draw, something of that nature. Okay, so now what I want you to do is I want you to measure the following angles. I need you to measure this angle here, and this angle here. All right, those three angles. Measure those three angles. Okay, now what you should have noticed is this is obtuse, and as you go this direction, they should go closer to this angle here, which is 90 degrees. Yeah, and you can see what I've got right here. You can see 72, 78, 85, 90. So what's happening here is as I go closer and closer to this tangent point E, these angles here get closer and closer to 90. And you'll notice that even if I were to move it closer to the actual circle, you'll notice it just goes to 51, 61, 73, 90. And of course, if I go farther away, you'll notice that they are just 77, 84, and 90. So it doesn't matter what happens, doesn't matter which side I go to. Well, actually, it does matter because of the angle we're measuring. But you could see here that as you get to this point right here, it's 90. So why is that important? Well, it's important because if you look right here from A to E to this right here, which is point C, these make right angle triangles. And because of that, we can use Pythagorean theorem. And later on, when we do circle geometry in high school, you'll be able to use the sine law and the cosine law. So let's get started. Okay, so as you notice, this is what you should have noticed as we got closer and closer to this point here, that the tangent is 90 degrees, and whenever you have a line which is tangent to a circle, it touches at one point, and it forms a 90-degree angle. Now, it only works if you're coming from the center of the circle out to the tangent point. So this is called the tangent point. And that is, the line is tangent to the circle, which means it touches in one point only. And it touches at what's called the tangent point. Now, if you measure the angle, you'll find that all tangent lines, no matter where you put this tangent line, if you marked it here and there, it doesn't matter where you put it or how many you put there, it's always, every tangent point is going to be 90 degrees. It doesn't matter. If I were to do over here, the tangent point from there to there, 90 degrees. If I had a tangent point over here, the tangent point from there to there, 90 degrees. Now, this is important because guess what this makes? Right angle triangle. Okay, so let's take a look at how you determine the measure of the angle in a triangle. Now, earlier in your grade, you were taught that if this is 90, which you just learned, and you knew this angle and you knew this angle, if you added angle G, angle O, and angle H up, you would get 180 degrees. Pretty straightforward. So if we know that this triangle has to have an interior angle of 180 degrees, what we're looking for is, what is angle H? Because we don't have to look for angle G, because we know that angle G is at a tangent point. And we just discovered from earlier up that any point on the tangent on the circle, any tangent point in the circle, is 90 degrees. So that means that angle G is 90 degrees. So we know that O is 59 degrees as given, and we know that angle G is 90 degrees. So what is angle H? Well, angle H will be 180 degrees, take away the 59 and the 90 to give you 31 degrees. What I'd like you to do is I'd like you to find the angle at O, please. So pause the recording and do this question, please. Okay, well, again, we know that this angle right here is at a tangent point, so angle D is 90 degrees, not a problem there. So we know that 90, and we have 100, we have 56, so we have to take 180 degrees, and we're going to take away these two numbers. And that gives us 180, take away 90, and take away 56, means that the angle at F here is 34 degrees. Okay, so we told you the Pythagorean theorem was coming. And the reason for that is that this angle right here at the tangent point is 90 degrees. Now, if we have a right angle triangle, FDO, and it's a right angle triangle, then we know that the Pythagoras theorem actually does apply. So we know that our Pythagoras theorem from before is c squared is equal to a squared plus b squared. And that works okay. In some textbooks, you'll notice that we have h squared. You'll notice that they've gone to that now because c is always the hypotenuse, so they just replace it with h to be the hypotenuse. And the a squared plus b squared doesn't change. So if you look over here at our example, we can give this an a or this a b. It doesn't really matter. I'm going to give this an a. I'm going to call this b. And of course, I'm going to call this h for hypotenuse. Now remember, your hypotenuse is always your longest side. All right, so we need to find out what A is. So the length A is going to have to mean that we rearrange our formula. I'm going to subtract B squared from both sides, and you've done this before, so we know that A squared, the second type of formula, is going to be equal to H squared take away B squared. This is an H here, okay? Now A is still our unknown. We don't know what that is. H is given to us at 72, and B is given to us at 60. So those are our formula and our substitution. So now I'm going to move down here to this other part here so we can just have the numbers done for us. So there is our formula. L was given as length. That doesn't matter. It's going to be H or C. So we have a substitution here, 72 squared take away 60 squared. Now 72 squared is 5,184. 60 squared is 3,600, and then you have to subtract them. Remember, order of operation, exponents comes before subtraction. That leaves me with 1,584 being a squared. So if I want to find out what a is, I've got to take the square root of 1584, and that is 39.80. So that means the length df from here to here, that length is 39.80 millimeters. Now I've rounded this off because this actually doesn't come out to be exact. You'll notice that. So this actually comes out to be 39.79 with a number higher than 5 there, so that rounds out to be 39.80. And yes, you need the 0 because we've rounded it to the nearest hundredth, so you can't lose that. Okay, so let's look at this one. In this case, we're given A, we're given B. Remember, here's our 90-degree angle. Now we're asked for the hypotenuse. Depending on which textbook you use, that could be a C or could be an H. And then sometimes they may even put in XO, depending on if you want to use the actual name of the particular side of the hypotenuse. And sometimes in a question, you'll find that they'll actually have a letter assigned for this. And if they use a question, like maybe, I don't know, say they put in K for here to here, then you'd have to use the K that's there. Either way, you set up your formula, and you'll have L squared is equal to A squared plus B squared. My L squared, previous to my last question, I said what it's called the length, so I'm going to use the L here. So length squared is equal to this squared plus that squared. So A is 60. Down here, this is my A, and this is my B, 66. So 60 squared plus 66 squared. Well, 60 squared is 3,600. 66 squared is 4,356, 4,356. You add them together, you get 7,956. Now to get from L squared down to L, you got a square root. So that means that L is going to be the square root of 7,956, which is 89.20. Okay, hopefully you get that. If not, go over it again. Try to do it by yourself if possible. This is the next type of question we get. And this is where we have something outside the circle, and you need to either find this or you're given it and you have to go here. But either this is the exact same question as we just did previously, except that you're given the distance from O to A is going to be 6,400 plus 1.4 kilometers. A variation on this question would be to find the 1.4, and we'll be doing that a little bit later. Okay. Now it says here, the small aircraft A, so there's your plane, is cruising at an altitude of 1.4 kilometers. Now obviously this is not to scale because if that was 6,400, there's no way that that could be 1.4. But we have to raise it up so we can see it, so it's not to scale. How far is the plane from the horizon? Now remember, the horizon is where the sun and the earth meet. So that's your horizon point right there. All right. So you can see that our horizon is at B. Okay, now, how am I going to do this? Well, if this is my longest side, it's my hypotenuse, and it's going to be made up of 6,400 and 1.4. So let's see what that looks like. Here's my setup. I'm going to be calling this L. I'm going to call A squared is what I want to find. So there's A, and I'm going to call this B. So I've got L squared is equal to A squared plus B squared. But since I want to find A, I rearranged my formula so that A squared is going to be equal to the hypotenuse squared, which is L squared, minus B squared. Now you can use a C or you could use an H here. It doesn't matter how you do it. All right. Now, A squared, we don't know, but that is the length from A to B. All right. L squared is the length from A to O, and B is the length from O to B right there. So here you see I've changed it into the actual letters on the triangle to give me length line segments. So once I have all the numbers in place, it's a matter of calculating them. Right, so I've got A, which is 1.4 plus 6,400, which gives me 6,401.4 minus 6,400 squared. And of course, that gives me, 40,977,921.96. And this is 40,960,000. You subtract those and you get not 17,921.96. And of course, when you take a square root, you get 133.87. So that means that the plane is 133.87 kilometers from the horizon. Okay, I want to do a couple of the more common types of questions for you so that you can see how to do them. This is finding internal angles, and if you look at it, it may look intimidating, but it's no different than the triangles that we had before. Here is your right-angled triangle. This is your tangent point, which means that this is 90. And of course, we're given that this one's 90, so that's not a difficult observation. So here's my triangle, 30, 90, and G. So what are the angles of D and E? Here's the key. The key to this question is to recognize that there are two angles given in this triangle. If you are not given this, you have to recognize that the angle at T on this side is 90 degrees, because otherwise you're given a 30 and a G and you don't know how to solve it. So this has to be recognized that this tangent point right here is 90. Of course, on this side, it may be easier for you because you see 90, but this is what you have to do. Recognize that that's 90. Once you know that, to find angle G, you just have to take and 180 degrees, because that's the internal angles of a triangle added up, and 180, take away 90, take away 30, gives you 60 degrees. Now, on this side over here, we've got angle F and 40 and 90. So angle F is going to be equal to 180, take away the 90, take away the 40, and that's going to leave us with 50 degrees. So that's a common type of question that you're going to get. The second type of question is the one that I've done previously for you already. And this is where you have like a horizon question. Now, in this particular type of a question, you can be asked for really only two different things. You could be asked for the distance from the drone to the horizon, or you can be asked for the distance from the drone to the surface of the Earth. Those are the only two things that you can be asked for. This here is always given as 6,400 because we know that from the surface of the Earth to the middle of it is roughly around 6,400 kilometers. Now remember that this here, right here, is also 6,400 kilometers. So this hypotenuse is made up of this distance and that distance added together. So if I want to find out the distance from the drone to the horizon here, what I have to do is I've got to recognize that this here is the 90 degrees. Once I know that's 90, then I know that this can be side A, and this could be side B, and this could be side C or hypotenuse, and I'm given this information, I can set up my Pythagorean theorem and I can get whatever I want. Right? If I want to find out what A is, this one here, I'm going to have to go A is equal to C squared take away B squared. If I want to take and find B, it's going to be B squared is equal to C squared take away A squared. If I want to find out what this length is, then I would have to go that C squared, the whole length, is equal to A squared plus B squared. And once I have the whole length, if I'm asked to find how high off the Earth the drone is, I take this complete length that I'm given, and I just subtract 6,400 from it, and that will give me this distance right there. So to continue to find the distance of A squared right here, what I need to do is to substitute out So substitute in the numbers. Now the 6400 is the radius of the Earth plus the 1.5 kilometers above the Earth. That's my C, my hypotenuse. And B right here is 6400 because it's the radius of the Earth. So adding them together, squaring them, subtracting them, square root, and you end up with 138.57 kilometers. Now that's the distance from here to here. Now you may ask yourself, if this is 1.5 and this is 6400, doesn't make any sense. This can't be 1.5. But remember when we went up here, everything is not to scale here. It's not possible to draw this to scale. If I did, my hypotenuse would look something almost exactly along that line there. It would be so close to the actual horizon point that you wouldn't even be able to recognize it. In fact, it would look very close to something like this here. Let's grab an triangle here. You would be looking at something which these two lines are so close together that they would almost overlap. And you can't even see the triangle there. So in order to make it clearer, what we've done is we take this and say, okay, look, this can't be like that. Let's put this over here, and we'll end up having an unscaled diagram in order to make it look better and easier. All right, let's look at another type of a common question. In this type of a question, we have what I would call the above the circle questions. Now, these questions can be like a horizon shot from here to here. How far is the satellite from the horizon? How far is the plane from the horizon? How far is the drone from the horizon? These are all very similar. Sometimes it's a hot air balloon from the horizon. Okay, and they all ask the same type of thing, but they all give you the same information. If they ask you for this, they're going to give you the radius of the Earth, and they're going to give you this distance right here, and they'll tell you how far above the Earth this particular item is, drone, balloon, or whatever. Sometimes, though, they'll ask you how high above the Earth is the actual airplane or the drone or the hot air balloon. And in that case, what ends up happening is they're going to give you this distance here, and they're going to tell you that that's 6,400 because the Earth is 6,400 kilometers from the crust down to the center of the Earth. And you're going to know what this is here. And they're also going to give you this distance on the outside. They're going to give you the horizon distance, if you want to call it that, or the tangent distance. So once you have that, you solve for this total distance and solve and subtract what this distance is because it's given to you. So let's go through one of those. And the question is going to be, how do you find XW? That's going to be our objective. Find XW given that ZO right here is 5 and XO right there. Oh, I got it wrong. This should be XY. That's okay. Change that to XY. XY should be 20. So we're given this one and we're given that one. Now, the key to doing this is to understand that there's some things here which are equal. And that is that all of the radius for the circle, radii for the circle, are all going to be the same and they're all equal 5 centimeters. The next important thing to understand is that the tangent point here and the tangent point there are 90 degrees. So that gives us two 90-degree triangles facing each other sharing a hypotenuse. That means that this here and that there are the same. It means that all of our radii are the same. So how are we going to solve this? Well, knowing that this is a hypotenuse and that this is a side, and we know this here is going to be 20 also over here, it's fairly straightforward because we just take our triangle, which is O, Z, and X, and we find out what is the hypotenuse here. So I'm going to pull that out, and you can see here that I've moved the 20 to here. I've got the 5 there. I want to find out what XO is. Well, this is my 90 right here. So being that's the 90, that makes this the hypotenuse. This here is A, or this is A or B or whatever. So these two are interchangeable, A or B. So here's my formula. H squared is equal to A squared plus B squared. Putting in the numbers, 20 and 5. That's 400 plus 25. Now, remember we square before we add. So when you put those two together, you get 425. So that means that this one here is going to be the square root of 425. So this is 20.61552816 ... going on. Now that means we got to round this off because we can't use all these numbers. So I'm going to round it off to the nearest hundredth, And since the 5 is greater, is 5 or greater, that causes the 1 to go up. So now I've got h is equal to 20.62. And to show somebody that this is an estimation, you put a dot over it. Okay, you can also put a tilde over there, but the dot works just fine. So now that I know that the distance from here all the way up to there, the whole hypotenuse is 20.62, I also know that this is a radii, from W into O is a radii, and from Y to O is radii. So this is a radii, it's a radius. If this is a radius here, we know that this radius is the same as that one. So that means that WO is 5 centimeters. So I'm going to take and find XW or WX. That's going to be equal to the whole thing, XO, take away WO. So it's 20.62, take away 5, which is 15.62. So that means that WX, the distance from here to there, now this could be, in this case, it's a picture hanger or a pendulum or something, right? So the distance of the swing point above the pendulum is going to be 15.62. Right? If this is a plate hanger, maybe the X is over here and it comes down vertically like that, then the distance above the plate from the pin to the plate, that would be 15.62. Right? These are all solved the same way. So if you have any problems, come and see me. I really advise you to take these last two questions and go over them and try to make sure that you can do them without any difficulty. Because if you do that, you're going to make this first lesson very, very easy to conquer. Okay, so we'll talk to you later.